MCQ 18 is a very common hydrocarbon question pertaining to free radical substitution for the case of alkane. So we're starting off here first by using propane, a 3-carbon alkane, and we're mixing it with chlorine. The question did not mention are we using limited chlorine or not, so I'm just going to assume that there is a possibility we can get dichlorination, trichlorination, monochlorination. So breaking it down, we're going to have this few steps. At the start, we're going to have your initiation. This is the part that ultraviolet light is actually important to allow us to go for our homolytic fission in order to generate chlorine free radicals to attack your propane. So we're going to have a Cl2 going through a homolytic fission to form 2 chloride free radical. But this is where everything has a little bit of a variation. We're going to look at propagation, and finally we're going to take a look at termination. We're just going to place this as pink as well as blue color to show you in each of the options that we're looking at what and how can we actually achieve it. And if we are going to achieve it, it's going to be at the propagation and or the termination step. Now, prior to me starting and going through, it's very important to know that no matter what is being done over here, for the case of propane, if let's say we're going to react with my chloride free radicals, we can only extract electron from hydrogen. So that means drawing it out, we have a CH3, CH2, and a CH3. We can only extract the electrons from my CH bond. So to draw this out a little bit more detailed, we're going to have C with 3 hydrogen, a C with 2 hydrogen, and a C with 3 hydrogen. Now the blue bonds cannot be cleaved no matter what. We can only extract the electrons from the following hydrogen. We cannot break our CC bond. This is the most important information. So we can break here, 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 or here, but we cannot break those that's in blue, which are the bonds that's found between your carbon. So in number 1 here, we're looking at the formation of your chloropropane. This is definitely not an issue. It can be generated from the propagation step. Not an issue, but it can also be generated from your termination step simply by having your propyl radicals to react with a chloride free radical. It becomes your chloropropane, as you can see over here. And just to reiterate, in your propagation step, you need 2 steps in order for you to get your chloropropane. The first one will be extracting a hydrogen to form HCl, and we're going to use our propyl radicals now to extract a chlorine from your regular Cl2, and from here we will be getting also your chloropropane, but also with the regeneration of a chloride free radical. So definitely option number 1, we can get it. Now in option number 2, we're looking for a dichlorination. You can see that 2 chlorine are actually being included here. So we're going to have a CH2, CH2, CH2. So we're looking at a 1,3-dichloropropane. So this itself can also be once again being generated in the propagation step. It can also be generation at the termination step. So taking at the termination step, we can use a chloropropane radical to react with another chlorine radical, and this will end up with our desired 1,3-dichloropropane. And we're going to take a look at the propagation step. If I'm just going to continue from this moment over here, a chlorine is going to extract another hydrogen, and this will form a HCl, continuing from here. So continuing one more step, the radical of this chloropropane will extract a chlorine from a regular chlorine, and this itself will end up by generating our 1,3-dichloropropane and also the regeneration of a chloride free radical. So 1 and 2 definitely are items that are to be seen. Now one of the most unique one that I hope students can understand is that for the case of free radical substitution, there is a chance of what we call as a chain expansion. This is a little bit different from your step-up reaction. Right? So in this case here, this can only be exclusively be formed from your propagation, your termination step. And this is formed through having 2 of your propyl radicals, propane radicals come together. And this actually allows us to generate our hexane from that. This is where two free radicals actually come together. You can see that the formation here is very much a multiple of the original number of carbon. I start out with a 3-carbon propane. So we can take a look. We are having an hexane here, which itself is a 6-carbon compound, and 6 is definitely a multiple of 3. So we can go on to go with a 9-carbon compound, a 12-carbon compound, but it has to be a multiple of 3. The reason why I'm saying this is because in option number 4, we have a total of 1, 2, 3, 4, and 5. We can't form a pentane because it has to be a multiple of 3 that is to be shown during the termination step. So based on this, 1, 2, and 3 are items that can be formed when propane reacts with chlorine in the presence of your UV light for free radical substitution.